Hello, today we are going to talk about taking our data from our Thomas the Train lab and using a graphing calculator to give us an equation for the data so that we can decide how fast it's going, and we can use that equation with another groups to see where they're going to collide after 3 meters. So let's talk about the calculator portion of this. Now, the way I just kind of made up some data for 3 trials, okay? And because most of you did it in some fashion in a similar way, where you set up a phone at a certain distance and then ran the train past that 3 times, so your distances remained standard and your times are what we're changing. So 3.1, 3 seconds, 3.5 seconds. So we're going to average the times. Now, if you kept your times in a particular gap, so maybe 2, 4, 6, 8, 10 seconds or something like that, then your distances are going to be what changed, and that's what you're going to be averaging. But what I did is I essentially, because time is what was changing in this experiment, I added the 3 times for 0.5 meters, and that average was 3.2 seconds. So on average, the train I used took 3.2 seconds to cover a half a meter. All right. And then we did the same thing with 1 meter, 1.5, and 2 meters. So I have this average data here. Okay. Now, what we want to do is we want to put that into the calculator and have it give us an equation. And we can even have it graph the data too. So let's do that. So when you get your calculator, it'll probably look something like this, where it's just a blank screen. And what we're going to do is we're going to hit this stat button here. Okay. And we want to edit our list. Now, L1 is the X value, or in this case, T for time, and L2 has to be distance. So L1 is time, L2 is distance. And I'm just going to enter those times in for L1. So my average times, all right? All right, and now I'll enter my distances in for L2. So 0.5 meters, 1 meter, 1.5 meters, and 2 meters. All right, so I have the X list and the Y list. All right, let's get our equation first, and then I'll show you how to graph it. Okay, because you can probably graph this by hand, but it's kind of a neat to see the calculator do it. So what I'm going to do is I'm going to hit stat again. Okay. And we want to calculate. All right, so we got to hit the forward button to get to that list. And then we want a linear regression. So it's going to take our data and try to get us a line of best fit. And this is essentially slope-intercept form, AX plus B. We use MX plus B, but this is our linear regression, okay, where the number in front of X is going to be our slope, which is actually going to be our velocity, okay? So I'm going to scroll down to 4 and hit enter. And then I just called up the program. I just got to hit enter to run it. And then here is the data. And this is why I'm pretty happy about this. This is telling me that the train is going about 15 centimeters a second, or 0.15 meters per second, and that the y-intercept, and I didn't even use 0, 0. I forgot to. I probably should have. That the y-intercept is less than a centimeter. Okay, in fact, it's a millimeter. So that's pretty good. If this number gets pretty high, then we've got an issue. All right. So what that means for me is that the equation is going to be distance equals, I'm going to just round to 2 decimal places, 0.15 t plus 0.00, we'll call it 8. All right. So that is the equation I will use with another group to calculate how long it's going to take for the 2 trains to collide after 3 meters. All right, and so let's do an example of that as well. I got time. So what you'll do when you get with your other group that I'll partner you up with is we'll take our equation, which was distance equals 0.15 t plus 0.008. I think I had right. Yep, and let's say another group's, let's say they had Spencer, a little faster train, and their equation was something along the lines of 21t plus 0.005. Okay, so we have these two equations. Okay, and these equations give us distance, and we know that together these distances are going to cover 3 meters. So if we add them together, so I'm adding them together with that addition sign right there, we're going to set it equal to 3 for 3 meters. Okay, and I combine like terms. That's a 5/8. All right. Subtract that from 3. And then divide by, oh, that's 36. There we go. And so what's that telling us is the time is going to be about 8 seconds before, oh, wait, that's not right. Let me do that again. Yeah, there we go. It's going to be about 8, we'll call it 8.3 seconds. Okay. And so what I would do then is I know that as these trains start coming at each other, okay, it's going to take the trains 8.3 seconds to cover that distance. So if this was my train and I wanted to figure out how far it's going to go in that 8.3 seconds, I'm going to substitute that 8.3 seconds into, time in my equation. So if I did that quickly with my calculator, all right, so I can slide this over. So we had 0.15 times 8.3 plus 0.008. And that's going to give me 1.25 meters. All right, so 125 centimeters. I know that my train is going to travel before it collides with the other train. So this is the part you're going to want to do with your group, okay, with your two groups together. So I hope this video helps. Remember, if you have any questions, come see me, and I'll talk to you guys later today.